So did you go through the methods of preparation from the previous class? Yes. Okay. We are discussing the preparation of this word, Gabriel thalamide synthesis, one of the important reactions in reduction of nitroalkanes, reduction of nitriles, right? Then we have in reduction of amides, then we see reduction of alkyl. These are some of the important reactions which are included in your syllabus, right? So can anybody tell me what is Gabriel thalamide? So what is Gabriel thalamide synthesis? Gabriel thalamide synthesis, okay, it is a method of preparation of amines where we can prepare primary amines, right? So what is our starting product? Starting reactant is we are going to take the thalamide. Okay, we are going to take the thalamide. Then with that, we are going to treat it with alcoholic KOH. KOH, what we are going to get, we are going to get a potassium thalamide, right? So a salt of potassium thalamide. Then this potassium salt of kept it with what? Alkyl halide, right? We are going to react it with alkyl halide. Then so what do we get? We get an N-ethyl thalamide, right? So this N-ethyl thalamide, further what we are going to do? We are going to do hydrolysis, right? We are going to do we are going to do base hydrolysis. Yes. So we are going to get a base hydrolysis. Okay, we are going to do a base hydrolysis, and then we are going to get the respective amine and a potassium thalate. Okay, we are going to get what? Potassium thalate. So potassium thalate. So this is a Gabriel thalamide synthesis. So I have mentioned in the last class, it is very important. Right. So we have seen. So we have seen all the six preparations. Right. So today we are going to start with the this what? Chemical properties. Okay, we are going to discuss the chemical properties. We are completed the physical properties also. Right. So let us see the chemical properties. Okay. So let us see the chemical properties. So first we are going to see the basic character of amines. Okay. Firstly, we are going to see the basic. So how is the basic amines, they amines, they react with acids. Okay. The amines are a base which are basic in nature. What do you mean by basic in nature? What do you mean by basic in nature? The pH will be more than 7. Right, pH will be more than 7. Now, when we are discussing about chemical properties, okay, chemical properties means what, how they react, right? So suppose we have amines, okay, okay, and this reacts with acid. HH is an acid, and your amines are base. So what we are going to get when acid and base reacts, we are going to get salt and water. So we are going to get N plus X, which is the salt, and plus we are going to get a water. Okay, we are going to get water. So when acid and base react, we get what? Salt and water. So you what amines react with the mineral and they form what? These are the ammonium salt. What it is as ammonium salt. Okay. And what it indicates? It indicates that the amines are basic in nature. So this confirms that amines are basic in nature. So this is the what you can say nature of amine is decided like this. Okay. So you are going to amines, you are going to react it with acid. What you are going to get? You are going to get the ammonium salt. Okay, this indicates that amines are basic in nature. Okay, now here you can see in the structure of amines, right? There are a lone pair of electrons present, right? Can you hear me now properly? So here on the amines, what you can see on the nitrogens, there are lone pair of electrons. These lone pair of electrons on nitrogen, they act as what? They act as a Lewis space. What do you mean by Lewis space? Lewis are those which uh, give lone pair of electrons. Okay. They have tendency to donate pair of electrons. Because of the pair of electrons present on the amines, they act as a donor. Okay. They act as a donor, that act as a what they learn. Okay. And okay, which are present on the nitrogen atom. So further are dissolved in water. Suppose now we take amines and we yes. Can you hear me now? Sorry, back. So what we were discussing the basic nature. Okay, we were discussing about the basic of amines. So that is what so we have so amines, they are basic in nature. How they are basic in nature? Because you can see that when amines, okay, they have a lone pair of electrons present on the nitrogen. So because of that, they can easily donate the lone pair of electron and they act as a Lewis base. So now this Lewis base, when we dissolve it in water, okay, so if we dissolve it in water, they will produce OH minus ions. So you can see they can produce as OH minus ions. So this is called as Arrhenius base. So they also act as Arrhenius base. So what do you, so we have studied this Arrhenius concept Okay, so in equilibrium chapter, in ionic equilibrium, okay, so in your first year, so what do you mean by Arrhenius base? So they have the tendency to give OH minus ions. Okay, when they have a tendency to give OH minus ions, then they are acting as a Arrhenius base. Okay, now so let us see the reactions. Let us see the reactions. So when amines react with water, they form RNH3 plus and OH minus. Okay. So if we take the equilibrium, if we take the equilibrium here, so the equilibrium ratio is given as K equilibrium. So we write reactant upon product, right? So take reactants, okay, reactants, and what is the product? Our product is RNH2 and water H2, right? So this is the equilibrium. Therefore, that is you if you take K equilibrium is to water, so what will be the Kb? So the Kb is given as so R NH3 plus OH minus, okay, divided by R NH2. So this is our equilibrium constant. What is Kb? Kb is nothing but it is the dissociation constant for weak base. So we have got what? We have got the dissociation constant for weak base. Okay. So this is our K equilibrium. So when we are finding the equilibrium, so higher the value of Kb, okay, stronger will be the base. Okay, stronger will be the base. So larger the value of Kb, what will happen? So as the value of Kb is larger, then strong base will be stronger. Okay, base will be stronger. So remember that. So larger value of Kb, the what base is stronger. Okay, and smaller value of pKb. Okay, smaller value of pKb. Okay, then stronger will be the base. Okay, stronger will be base. Why? Why? Because your pKb. So we know that pKb is equals to minus log of Kb. Okay. So remember this. So stronger, larger the value of Kb, stronger will be the base, and smaller the value of pKb, stronger will be the base. pKb and Kb are different terms. Okay. So we are measuring the amines. So this is about your amines. Okay, this is about your basicity of amines. So amines, they act as Lewis space, they act as Arrhenius space. Okay, so this is the property or you can say basicity of amines is decided. So next we are going to see the structure. So these are the different, you can see different amines. So different amines and their pKa value. Okay, they are pKb, not pKa. So this is their pKb value of their conjugate acids. Okay. So this is the diethylamine, dimethylamine. Okay. So these are the different values of this. Okay. So let us go for the next one. So okay, next we will see the structure and basicity. Okay, next we are going to see the structure and basicity, okay, relationship. So the basicity of amines, okay, it depends upon the ease of formation of cation from the acid. We have seen just now. So if we have a amine, okay, we have a low pair of electrons on nitrogen. Suppose we react it with water. So what we are going to get? We are going to get a salt. Okay, we are going to get the RNA plus. So we are going to get a substituted ammonium ion. This is what substituted ammonium ion. Okay, we are going to get substituted ammonium ion plus OH minus. Okay, plus OH minus. So here, what is happening here? So the basicity of amines, it depends upon the ease of formation of cation by accepting a proton from the acid. Okay, so more the stable the cation, more is its basic character. So we have seen that also when we have amines, okay, and when we react it with the acid. Okay, so what it will do, this amine, it will take the hydrogen, okay, proton from the acid, and we are going to get what? R NH3, okay, plus X. So we are going to get the salt, right? We are going to get a substituted salt. So it has that ease, okay, it has that capacity of accepting the proton. Okay, so similarly, ammonia. Now this was about amines. Okay, this was about amines. Now when we talk about ammonia, so this is our ammonia. What are amines? Amines are nothing but the substituted derivatives of ammonia. So we have ammonia. We react with water. What we are going to get? We are going to get a ammonium ion. Okay, we are going to get the ammonium ion. So here, when we say alkyl amines, so these are alkyl amines and these are ammonia. So amines are more basic than ammonia. So when we are discussing about ammonia and amines, our alkyl amines are more basic. Why? Because R, okay, there is an electron donating group. So there is a presence of electron donating group. Okay. So the alkyl group is electron donating group. So because it gives the electrons, okay, to the ammonia. So because of which the electron density on nitrogen atom will increase. Okay. And because of which the lone pair of electrons on the nitrogen, they are easily available, okay, for donation or protonation. So this is about your alkyl amine. So when we are discussing about amines and ammonia, our alkyl amines are more basic in nature. Why? Because we have an electron donating group. We have an electron donating group. So this electron donating group, because of which the plus effect increases. Okay, plus effect will be more, and what will happen? It will increase the electron density. So the electron density on the nitrogen atom will be more. Okay, so because of which the lone pair of electrons can be easily available for protonation or donation. Okay, now here we can see it forms also the substituted ammonium ion. So this substituted ammonium ion, okay, it is stabilized. Okay, it is stabilized because of the presence of the positive ion. Okay, so the basicity of aliphatic amines, it increases with increasing number of alkyl amines. So when we talk about tertiary amines, so tertiary amines are more stable, then our secondary amines, and then our primary amines. Why? What is the reason? Because as the electron donating group will increase, the basicity will increase. Okay. So electron donating groups, if they are more, so what will happen? Plus side effect will be more. Because of that, the lone pair of electron available on the nitrogen, it will be easily available for donation or protonation. Okay. So tertiary amines are okay. Is it clear up to you? Is it clear? Any doubts up to your students? So this was about our alkyl amines and ammonia. Okay, this was about alkyl amines and alkyl amines. Now we will see about aryl amines. Okay, aryl amines versus ammonia. Okay, aryl amines versus ammonia. So previously what we saw, alkyl amines and ammonia. Now we are going to say aryl amines and ammonia. Now, when we have a ammonia, alkyl amine. So this is our alkyl amine, right? Aryl amine, sorry, that is aniline. Now, when we talk about aryl amine are weak bases. Okay, they are weak bases. Then ammonia. Then our ammonia. Okay, in case of alkyl amine, what it was? Alkyl amines are stronger bases, okay, base than your ammonia. But here in this case, what you can see that the aryl amines are a weak basis than ammonia. Why? What is the reason? Because the NH2 group, which is attached to the benzene ring, will show the plus M effect. This, okay, so your NH2 group, this NH2 group which is attached to the benzene ring, okay, it is showing plus M effect. Okay, so as a result, the lone pair of electrons on nitrogen, they are involved in conjugation. Conjugation means what? So because of the because nitrogen, okay, so this will undergo conjugation, so they will undergo the bond formation, so like this. So it will undergo what? It will undergo like this. Okay. Uh, so it will, so the negative, the electrons are not freer. They, because the lone pair of electrons, they are not available. Okay. So they are not involved So they are involved in conjugation. They are not freely available because of this reason. Okay, what will happen? Because of this reason, what will happen? The aryl amines are less basic. Okay, the aryl amines are less basic. Is it clear? So this is the reason. So I'll show you. Okay. So I'll write the complete conjugation. So here minus. Okay. So plus. So again, this charge is resonance stabilized. Okay. So we are going to. So you can see that what is happening to the charge. Okay. So like this, the electrons are involved in conjugation. Okay. Like this, the electrons are involved in conjugation. So the free electrons, the lone pair of electrons on the nitrogen, they are not freely available. So they will undergo what? They will undergo resonance electron or stabilization. Okay. So you can see the lone pair of electrons, they are available in the conjugation. Right. They are available in the conjugation system. So because of that, they are what? They are not available for protonation. Okay. They are hence they are less available for protonation. So, and suppose we have ammonia. So when we see the aniline ion, okay, so when we see the stabilized structure, so suppose now if we have a ammonia, suppose we have a ammonia now, okay, sorry, aniline, and we are taking one proton. So what it will do, this will take the proton, and what it will form? It will form a aniline ion. Okay, it will form a aniline ion. So this aniline ion is less stable. Okay, this is less stable as compared to your ammonia, than your aniline. Okay, so because of that, your aryl amines, okay, they are more, what you say, they are basic. They are basic in nature. Okay, your aryl amines, they are basic in nature as compared to your ammonia. Okay, aryl amines are less basic in nature. So they are less basic in nature. Okay, fine. So this was the first property. So first chemical property, that is your chemical property of amines, that is basic nature or basic character of amines. So we have seen both in terms of alkyl amines as well as the aryl amines. So now we will see the next chemical reaction. So next chemical reactions, first we will see alkylation. Okay, it will undergo alkylation reaction. So how they undergo alkylation reaction? So take amines. So these are the aliphatic amines, primary amine. So this primary amines, I react it with alkyl halide. Okay, if we react it with alkyl halide, what you are going to get? We have seen this ammonolysis, right? So what will happen? Two. So one of the hydrogen will be replaced by your R, right? So you get R2NH, right? You get a secondary amine. You get a secondary amine. So with the removal of HX, with the removal of HX. Now again, suppose I react it with one more mole of alkyl halide. So there will be removal of HX, right? And what you are going to get? R3N, right? We are going to get R3N. So we are going to get a tertiary amine. Now again, I react it with alkyl halide, right? So what I am going to get? I am going to get a quaternary ammonium salt. What I am going to get? A quaternary ammonium salt, right? So, so this is the reaction. So amines, they react with the excess of alkyl halides. Okay, and at every step you can see one of the hydrogen atom is of the NH2 group. Okay, is replaced by the alkyl group. And what it forms at each step you can see you will get the primary amine, secondary amine, tertiary amine, and finally we are going to get the quaternary amine salt, wherein all the hydrogen atoms are replaced. Okay, you can see that at each step, after supplying one mole of alkyl halide, what you can observe that uh, the alkyl halides, okay, one of the at each step, so hydrogen replacement takes place and alkyl group is attached. Okay, so this is the about your alkylation. Is it clear? So amines, they react with excess of alkyl halide. Okay, and at each step, the replacement of hydrogen atom of the NH2 group. Okay, we are replacing each at each step, hydrogen atoms are replaced by the alkyl group, and we get respectively secondary, tertiary, and finally we are going to get a quaternary ammonium salt. Is it clear? Is it clear? Alkylation. Okay. So next is acylation. So this was the second one. First one we have seen is basicity of amines. Okay, first chemical property which we have seen is basicity of amines. Second is alkylation. Third one is acylation. Third one is acylation. Okay, so what we are going to take? So we are going to take primary and secondary amines. Okay, we are going to take primary and secondary amines. And these primary and secondary amines, if we treat, suppose, so this is what? Ethyl. Okay, this is ethylamine. So this is a primary amine. Okay, so we have taken ethylamine. This is our primary amine. So this primary amine, I'm going to react it with acylation means what? I have to take a acyl chloride, CHC chloride, right? So it is a acetyl chloride. So let us take a acetyl chloride. So acylation, alkylation means we are going to take alkyl chloride, right? Now here we are going to take a acetyl chloride. So what we are going to get now? So what we are going to do now? So we are going to take a ethylamine. We are going to react it with acetyl chloride in the presence of pyridine. So pyridine is a base. It is a base. The lone pair of electrons present on the nitrogen will attack the carbonyl carbon. Okay, so what we are going to get? So C2H5, okay, NH. So one of your hydrogen atom will be replaced by your acetyl group. Okay, acetyl group and HCl. So what I'm going to get? I'm going to get N-ethyl, N-ethyl, N-ethyl ethanamide. Okay, N-ethyl ethanamide. Okay, or you can say N-ethyl acetamide. Okay, N-ethyl acetamide. So this can also be the name given, or N-ethyl acetamide. Okay, fine. So this is the name. So this was the acetyl acylation. So one more reaction of acylation. So this we have taken with primary amines. Okay, now let us see, take a secondary amine. Now let us take a secondary amine and let us see what will be the product. Okay, so let us see a secondary amine. So this is with the pyridine. Okay, this is with the pyridine. So let us take a secondary amine, which I'll take. I'll take a diethylamine. Okay, so diethylamine. So N C2H5H. Right. This is a diethylamine. Diethylamine. I'm going to react with this acetyl chloride, that is CH3 C double bond O Cl. Can anybody tell me the product? Yes, what will be the product, students? What will be the product? So, lone pair of electrons for nitrogen will attack the carbon in carbon. What I'm going to get? I'm going to get C2H5, N, C2H5, right? Then C double bond O, CH3 with HCl, right? So, what I'm going to get? NN diethyl acetamide, okay, or ethanamide. Ethanamide. So this is the product obtained. Understood? Yes. So this is the product obtained. So this is another acylation reaction. So another acylation reaction with the secondary amine. So primary and secondary amines, they undergo acylation reaction because there is a availability of protons. Okay, so easily the proton can be replaced by the acetyl group, right? So because of that, only primary and secondary amines will undergo acylation reaction. So let us see with one aniline. Okay, so we'll do the acylation on aniline. So next reaction. So okay, I'll take a aniline and I'm going to react it with acetic anhydride. What is acetic anhydride? So this is acetic anhydride. Okay, this is acetic anhydride. So what will happen now? So one mole of acetic anhydride is broken. So what will happen now? So NH. So one of the hydrogen will be replaced by one of the, okay, and you are going to get acetic acid as the byproduct. So I'm going to get N-phenyl ethanamide. Okay, N-amide ethanamide. Fine, or it is acetanilide. Acetanilide. So this is our product, and this is acetic acid. This is acetic acid. Understood? So this is the another uh, chemical. Yes. So which all chemical properties we have seen? First, we have seen the basic basicity of amines. Second, we have seen the alkylation. Okay, second, we have seen the alkylation. And the third, we have seen the acylation. Okay, third, we have seen the acylation. Okay. So what is the reason why tertiary amines do not undergo acylation, students? Just now I've told you. Just now I've told you that tertiary amines are not undergoing acylation. Why tertiary amines are not undergoing acylation? Yes, it can be a question. So please note it down. Please note it down. Why tertiary amines do not undergo acylation reaction? Yes. So tertiary amines, they do not, please note it down. So they do not undergo acylation. Why they do not undergo acylation? Because because they do not contain replaceable, replaceable hydrogen atom. Okay, bonded to nitrogen. So remember that. So remember this. So primary amines, right? This is primary amine. Secondary amine and tertiary amine. So what you can see the difference, primary, secondary, and tertiary. So here you can see that there are two replaceable hydrogen atoms. Here one, here there is no replaceable hydrogen atom. So because of this reason, tertiary amines, they do not undergo what? They do not undergo acylation. Okay, only tertiary amines. Understood? Yes, is it clear? Yes. Okay. So suppose we have this methylamine. Suppose we have a methylamine. Okay, we have a methylamine and we are going to react it with C6H5 C double bond to Cl. This is what benzoyl chloride. What it is? It is a benzoyl chloride. In the presence of again pyridine. Okay, pyridine is our base. What will be the product? So the lone pair of electrons from hydrogen will attack the carbonyl carbon. We are going to get CH3N. So one will be hydrogen, another will be what? C double bond O C6H5. Right. So this is the product of it. So what is the name? The name of this is N-methyl. It is N-methyl benzamide. It is a N-methyl benzamide. Okay, N-methyl benzamide. Okay. So methyl amine benzoyl chloride. Okay, when it reacts, it gives you N-methyl benzamide. Okay, and this reaction is called as benzolation. Okay, please remember that this reaction, name of this reaction is benzolation. Okay, benzoylation. Benzoylation. Okay, LATION. Okay, so this is what benzolation. Understood? So remember this. So methylamine, when we are reacting with benzyl chloride, again the lone pair of electron from the benzene is attacking the carbonyl carbon, and we are going to get the N-methyl benzamide. Okay, so this is name reaction is called as benzylation. Benzoylation. Okay. Next important reaction, it is carbyl amine. So carbyl amine reaction. Next important reaction is carbyl amine reaction. Okay. So very important. Mark this as important for 3 marks. Mark this as important for 3 marks. Yes, 2 marks. Sorry. So we have a primary amines. Okay, primary to react with chloroform in the presence of a alcoholic KOH. Okay, in the presence of alcoholic KOH, so we have a primary amine. We are going to react it with chloroform. Okay, we are going to heat it. We are going to heat it in the presence of chloroform and alcoholic KOH. We are going to get isocyanide. Okay, what do you mean by isocyanide? Yes, RNC. So this is this when the attaching atom is nitrogen, right? Then we get isocyanide, and this is CN means what? You get cyanides, right? So when the attaching group is C carbon, then it is a cyanides. But when the attaching atom is nitrogen, then we get what? Isocyanide. So remember that, don't forget. So what we are going to do, we are going to take the primary amines that we are going to heat it, okay, with the mixture of chloroform and alcoholic KOH, we get isocyanides. What we get? We get isocyanides, okay. And this isocyanides, so these will have a very bad smell. So these mixture will you will get a very bad smell, or you can say it is having a false smell. So you get a very false smell. So I'll give you example now. So I have you tell me the answer. So I have taken methylamine. Okay, I'm going to react it with CHCl3. Okay, CHCl3, yeah, not CH3Cl, CHCl3. Chloroform is CHCl3. I'm going to react with 3KOH. Okay, so what we are doing, I'm taking a methylamine, okay, methylamine, and I'm heating it with chloroform and alcoholic KOH. I'm heating it with chloroform and alcoholic KOH. Can you tell me the product now? Can you tell me the product? Anybody? Yes, what will be the product, students? What will be the product? What will be the product? Our R is our methyl group, and we are going to get what? NC. So we get what? Methyl isocyanide. We get methyl isocyanide plus 3KCl. Okay, your the side products are 3KCl plus 3H2. So similarly, 3KCl plus 3H2. Okay, one more example. So I'll write the example here only. So let me substitute R as, let me take a arylamine. Okay, let me take a arylamine. So this is your aniline. Okay, so this is our aniline. So primary amine, but primary aromatic amine. So this is our aniline. So aniline, I'm reacting with chloroform and alcoholic acid. Okay, I'm heating it. So what I'm going to get, see what I'm going to get. Tell me the product, students. Tell me the product. Tell me the product. What will be the name? Can you tell me? So what will be the name? So it will be benzene, right? With NC. So this is phenyl isocyanide. Phenyl isocyanide. Is it clear? Is it clear? Carbalamide reaction. Carbalamide reaction. Very, very, very important reaction. 2 marks question. Explain carbalamide reaction with an example. Explain carbalamide reaction with an example. Yes. Okay. So here, this carbolamine reactions, only primary amines. Okay. Only primary amines will undergo the carbolamine reaction. So for testing the primary amines, we do carbolamine reactions. Okay. So only, so remember that only primary amines, only we can prepare primary amines from carbolamine reaction. Okay. Is it clear? Yes. Is it clear? Okay, so we have few more. So we have few more reactions. So let us see. So few more reactions are there. Okay. So next is, so this was the fourth one. Okay. So what all we have seen? Chemical properties. So what all chemical properties we have seen? First we have seen basic nature of amine. Second one was alkylation. Third was acylation. Fourth was carbolamine reaction. Next is the reaction with nitrous acid. Next is reaction with nitrous acid. Okay, what is nitrous acid? HNO2. Okay, and how you get this HNO2? When NaNO2, that is your sodium nitrate, is reacted with HCl. Okay, you get HNO2. So remember that how you get nitrous acid. This is nitrous acid. What is nitrous acid? HNO2. Okay, HNO2 is called as nitrous acid. So how you get nitrous acid when your sodium nitrate. So this is our sodium nitrate. So sodium nitrate is treated with hydrochloric acid. Okay, hydrochloric acid. So what we are going to get? We are going to get a nitrous acid, HNO. So let us see the reaction. So we have our amine. Okay, we have a primary amine. So important, mark this is important for 2 marks. Mark this is important for 2 marks. Okay, fine. So we have a aliphatic amines. Okay, we have a primary amine. We are reacting with nitrous acid. How you get nitrous acid? When sodium nitrate is reacted with HCl. Okay, when sodium nitrate NaNO2 is reacted with HCl. Okay, when NaNO2 is reacted with HCl, what we are going to get? Nitrous acid. So what we are going to get? We are going to get a diazonium salt. Okay, we are going to get a diazonium salt. So about diazonium salt, so we are going to study after this, after completion of chemical properties. It's there for your syllabus. So we are going to take a primary amine. Primary amines, we are going to react it with nitrous acid. How we get nitrous acid? We get nitrous acid when NaNO2, that is your sodium nitrate, reacts with your hydrochloric acid. Okay. So what R we can take? Either we can take methyl, we can take ethyl group. Okay. So we can take what we are going to get. We are going to take diazonium salt. So this is an intermediate. This we are going to treat it with water. Then we are going to get alcohols plus N2 gas plus HCl. Yes. Okay. So we are going to get alcohols. So from primary amines we can get alcohols by doing diazotization. Okay. So this process is called as diazotization reaction. So this is called as diazotization reaction. So what we have done? So we have taken a primary amine, we are treating it with nitrous acid, we get a diazonium salt. This diazonium salt upon hydration, okay, what we are going to get? Alcohols plus N2 gas is liberated, nitrogen gas is liberated, and HCl gas is also liberated. Okay, so this is with aliphatic amines. Okay, suppose this is a, suppose we have a aromatic amines. Suppose we have a aromatic amines. Suppose I'll take aniline, our primary, this is aniline. Okay, aniline. Again, we are going to do what? What diazotization? How? We are going to take NaNO2 and plus HCl. Okay, NaNO2 the temperature condition is 0 to okay 0 to 5 degrees Celsius or 270 to 278 Kelvin. So what we are going to get? So by this, what we are going to get? We are going to get nitrous acid, HNO2. What we are going to get from NaNO2 plus HCl, we are going to get nitrous acid. Now, aniline, when it reacts with nitrous acid, what we are going to get? We are going to get again N2Cl. Okay. So this is what we are going to get a benzene diazonium salt. Okay, we are going to get benzene diazonium chloride. Benzene diazonium chloride. This benzene diazonium chloride, okay, plus NaCl plus OH2. Okay, so aromatic primary amines when they react with nitrous acid and the condition is low temperature, that is 0 to 5 degrees Celsius. Okay, we are going to get the benzene diazonium chloride. That is, we are going to get the salts, right? And this reaction is called as what? Diazotization reaction. Okay, diazotization reaction. So important, that's important for 2 marks again. So very important, 2 marks question. So both these questions are important. So diazotization. Okay, D-I-A-Z-O. D-I-A-Z-O. D-I-S-A. Diazotization reaction. What we have done, we have taken a primary aromatic amines, we are reacted with nitrous acid, and we got benzene diazonium. Okay, so this reaction is called as what? Diazotization reaction. With aliphatic amines, okay, we are doing, so the intermediate we got at diazonium salt. Further, when we do hydrolysis, we get alcohol. Okay, so these are the reactions. So we are left for chemical properties. So there are some more two. So two, three chemical properties are there. So that we'll be seeing, okay, in the next class. So we require some 2 to 3 classes more, okay, for completion of this chapter. So this is a very small chapter. So we require maximum 2 classes for completion of this particular chapter. So this is a very small chapter, okay, and the concepts are short but very important. So we have seen what all are the important things. So please go through the things. So I'll just revise. So what all we have discussed about what are amines, okay? What are the classification of amines? Then we have discussed about the nomenclature. So nomenclature is very important. So please study the nomenclature. Then please study the structure of amines. So we have discussed the structure of amines also. Then preparation of amines. So we have studied 6 preparations. So out of that, so the most important 2 preparations are the Hoffman-Bromamide degradation reaction and the Gabriel-Thalamide synthesis. Okay. All the new reactions, all the reactions, 6 preparations are important, but these 2 preparations can be asked one degradation reaction. Then we have studied the physical properties also. Right, then we have started today with chemical properties. So we have studied first the basic character of nature. Okay, basic character of nature, yeah, amines. Then we have discussed the basicity of alkyl amines versus ammonia, as well as basicity of aryl amines versus ammonia. So that also we have seen. Then we have discussed about alkylation, the second property, chemical property. Then we have discussed about acylation. Then we have discussed about carbalamine reaction, very, very important. Then we have discussed about reaction with nitrous acid. Okay, we have discussed about nitrous acid. Then we have discussed about, okay, then we have discussed about the, what? We have discussed about the diazotization reaction. So that's all we will be discussing weightage. Okay, just 2 minutes. Okay, I'll tell you. It is for 8 marks. Okay, 8 marks. So this chapter is for 8 marks. Amines. Okay. And the previous chapter, coordination compounds, I have told you, it is for 12 marks. Okay. So coordination compounds. So I'll be uploading the notes on coordination compounds as well as amines. Okay. So please go to the notes. Fine. Okay. So By this, any other doubts you have? Okay, fine. So let me end the session here. Okay, so we'll meet in next class. Thank you. Have a good day.